Okay, now we're going to look at number 2. Now, this one is a little bit different because first of all, we don't have a Venn diagram, but also not all of the numbers given to us are already in probability form. So in number 1, everything was already as a probability. It was a decimal in between 0 and 1. But here we're given numbers of things, just the amounts instead of probability. So we're going to look at that. So number 2 says a suburban high school has a population of 1,376 students. The number of students who participate in sports is 649. The number of students who participate in music is 433. So far, all 3 of those numbers given to us are not probabilities. Those are just number of students. If the probability that a student participates in either sports or music, that's our union, is 974 out of 1,376, and that number is a probability. What is the probability that a student participates in both sports and music? Okay, so anytime that we have 2 separate events and then we have a union and an intersection and we know one and not the other, this is when we have to use our addition rule formula, okay? So this formula is definitely what we're going to be using here. All right, now the part that we're being asked to find is the intersection. So that's going to be our x. Now what we're going to do is go back and now plug in all of the other missing pieces. And we have to make sure that everything is written as a probability. Okay, so the union here, we know the union, and luckily for us, it's already written as a probability. So that's nice. But the next two values, the sports and the music numbers, they are not written as probabilities. Okay, so they are only given to us as numbers. But we can easily turn those into probabilities by putting them over the totals. Okay, so the probability that a student plays sports is 649, that's how many play sports, out of the total, 1,367. And then the same is true about music. 433 play music out of the total. Okay, so that's how we're going to find a probability, is we just put it over the total amount. Okay, and now we have this missing piece, and I like to change it into an X just because it's a little bit simpler to work with than the probability symbolic notation. And now we're just solving. Okay, we're solving here. It looks yucky because all of these fractions, but you're using your calculator, so it's okay. First, I want you guys to combine your like terms on that right side. All right, and then you're going to end up with just one fraction minus x, and then you are going to solve for x. Okay, so combine these. What goes here? Solve for x. And what I want you guys to do is write your answer as a fraction in simplest form. If you're using your calculator, it should automatically be simplifying it for you. All right, so you're going to enter in that answer, and then the last thing you're going to do today is number 3. Now, I just want to point out, number 1 that we did before was done all in decimals because everything in the problem was already written as probabilities in decimal form. So there was no need to wonder or change anything. We just kept the same form. Number 2, we worked with fractions because we were given one of the probabilities in fraction form. So we kept everything as fractions. And number 3, everything's as percents. So you can just work with percents. Make sure your answer is in a percent. Okay? All right. Good luck. Try to think about what questions you have, and we will go over them tomorrow. And we're going to just keep building from here.